we have some interesting kinds of questions today, although they're probably a little better than yesterday. So just to review a few properties, if something has the same base in a product, so x cubed times x to the fifth would be x to the 8. So we're allowed to add the exponents if they have the same base, only if it's multiplication. What if it was x cubed over x to the fifth? Subtract the exponents. Very good. And the way that you subtract is top to bottom. Top minus the bottom, which in this case would give you x to the negative 2. And then, what is x to the negative 2? Yeah. 1 over x squared. Good. Remember, that negative sign says I'm unhappy up here, and I want to flip down into a denominator position where now I'll be totally happy. Okay? Those are the rules in a nutshell. And also, we can multiply powers together. Let's see. A to the 4th divided by b squared all to the cube. What do you do in that case? 3. Oh, yeah, that's better. That works better. Yeah. So this is power raised to a power. And in this situation, we can multiply those exponents. And I have so many things going on in my head right now that I can't write today. All right. So that's going to be a to what power? A to the 12th over b to the 6th. Good. Okay. And so when you have a power raised to a power, you can multiply those powers. Otherwise, add and subtract powers is always useful when they have the same base. Okay. So let's practice a little bit here. Ejemplo 1. Simplify. Express results with positive exponents. With positive exponents. I don't know what happened there, but whatever. Doesn't mean that, God bless you. Doesn't mean that you have to start with positive exponents. It just means that your final answer must have positive exponents only. Okay, so that'll apply in a little bit. So your final answer should have positive exponents. Again, make sure that you're writing down this example 1, simplify, positive exponent result with positive exponents. Write those directions. That's how I grade your notes. Okay, so those are kind of important. Simplify. Okay. And again, if you know the answer, feel free to work ahead. All right. So on letter A, what situation is this? Where you can multiply the exponents. Sure, we have a power to a power. Power raised to a power, so we get to multiply those exponents on top and bottom. What does that give you? X to the 15th over y to the 3rd. And again, that's y to the 1st power raised to the 3rd, y times y, or y cubed. All right, that was easy. What about B? Okay. Okay, very good. So this is a fraction, 21 divided by negative 3. You can reduce that fraction, and that's going to give you what? Negative 7. And then here, a to the 8th divided by a cubed. They have the same base. And what can we do when they have the same base? Subtract the exponents. So my base stays the same, and we're going to do 8 minus 3, which is 5. So we get negative 7 a to the 5th. All right, and could you do that in one step? Absolutely. Okay. All right, questions on those? Pretty easy, right? Pretty good. Glad you think that's easy. Okay, good, we're good. I hear chatter. I just want to make sure you're not. Okay, whoa, that's a lot of. Little bit of a change there, huh? Yeah. All right, so letter C, 5, a to the negative 3, b to the negative 1, c to the negative 3, times the quantity 3, a to the negative 2, b, c to the 7. So, looks really long, looks really complicated, but ultimately this is one giant multiplication problem, right? Are those parentheses really helpful here? Are they absolutely necessary? No, not so much. So the thing we want to remember is that multiplication is commutative. We can rearrange these however we want. 4 times 5 is the same as 5 times 4. So if I wanted to, this is one giant multiplication. Everything's being multiplied. And so things that match up, we can move around and multiply them together in any order we want. So we're going to multiply 5 and 3 because those are just plain old numbers and get what? 15. A to the negative 3 times a to the negative 2. They have the same base. What should you do with those exponents? Add them. So that's going to be a to the negative 5. Negative 3 plus the negative 2. Add those together. All right. Then we have b to the negative 1 times b to the first. B to the negative 1 times b to the first is going to give you b to the 0. Why? Negative 1 plus 1 is 0. Very good. So that is just 1. We'll get rid of that on the next go around. And then c to the negative 3 times c to the 7th is going to give you c to the 4th because you add the exponents. Negative 3 plus 7. Okay, so this is great. This is a lovely answer, but the direction said our result must have positive exponents. So we have one issue, and what's that issue? A to the negative 5th. Is he happy or sad? He's sad and he wants to go where? Into a denominator. So we're going to move him down. And what about b to the 0? What is b to the 0 really? It's not 0. It's 1. Okay. So it's 15 times 1 or 15 in a numerator. C to the 4th is happy upstairs in numerator land. And a to the negative 5th is moving down to denominator land where he will now be a happy camper. Okay. Okay? Are you okay with that? It's my happy camper math. Okay, letter D. Negative 28 x squared y cubed, all divided by 7x to the 4th, y to the negative 2. All right. What do you want to do? You can divide the numbers, sure. Negative 28 divided by 7, we can clean that up. What is 28 divided by negative 7? Negative 4, yeah, good, okay. All right, what about these x's? We got x's, they have the same base. So x squared divided by x to the 4th, what do you do there? Subtract the exponent. So that's going to be x to the negative 2 because we just did 2 minus 4 and got negative 2. And here we have y cubed divided by y to the negative 2. They have the same base. So we're going to keep that base and do what with those exponents? Subtract. How does that work? It becomes about, yeah, 3 minus a negative 2 and minus a negative. Yeah, so it becomes 5. You do have to be a little bit careful. Again, there's lots of ways to do this, but today my focus is using the rules. All right. Negative 4 is perfectly happy where negative 4 is. But what should we do with x to the negative 2? Denominator. Move them down to the denominator. And y to the 5th is also perfectly happy upstairs. When we move x to the negative 2 to the denominator, he's now a happy camper. All right. Raise your hand if you've got this. Thank you. Okay. So those were pretty easy. So now, letter E. Let's look at letter E. So lots of stuff going on here. I think before I deal with this outside negative 1, I want to try and clean up everything inside first, because I definitely see stuff that I can clean up within the parentheses. Okay? So with that in mind, inside these parentheses, so I'm not dealing with this thing yet. First, I've got a 12 over 3, and I can simplify that to what? 4. Okay, 12 divided by 3 is 4. Then I have a to the n plus 2 over a to the n minus 3. They have the same base of a. So what are we going to do with those exponents? Subtract them, yeah? So how do we do that? Write it down. Okay, so good idea. Write it down. So that would be n plus 2 minus n minus 3. The top minus the bottom, right? What do you have to do with that negative? Distribute it. That's the tricky part here. N plus 2, I need to subtract the entire denominator, the entire exponent there, becomes negative n plus 3. What happens with those n's? They cancel out, and we're left with 5. Hey, that was handy. All right, and then here, b to the negative 2 over b to the negative 3, they have the same base. And what are we going to do to those exponents? Subtract them. So negative 2 minus a negative 3 is 1. Okay. So that's a lot neater, a lot cleaner, right? Now that I've cleaned up inside, what do I do with this outside power? Distribute it. And it goes everywhere, right? Even to the 4? Yeah, because the 4 has its own little exponent. All right, so that's going to give me 4 to what power? Negative 1. And then a to what power? A to the negative 5. Good. 5 times negative 1 is negative 5. And then b to the negative 1. Okay. They all move to the denominator because they're all unhappy. All right. Good. So 1 over 4. A to the happy 5. B to the happy 1 now, which you don't really need to write. Question 3. Think you got it?
Yes.
Yes. Oh, enthusiasm. How about that?